welcome back. It's great to have you all here and listening to my voice today. We are finally going to be starting into Chapter 1. So these slides will look a little bit different than what we've done, or what we've seen in Chapter 0. So the title is going to be up here. This is the distributive property. This, again, is going to be your section number 1.1. I'm also going to have this CCSS, which stands for Common Core State Standard. So today, the standard is A.SSE.1, which stands for Algebra something something E1. Not sure what that stands for, but something with algebra. Probably simplifying some type of expressions or equations. Who knows? Someone knows. Anyway, interpret parts of an expression is the gist of it. Some vocab, distributive property, coefficient, term, like terms, and constant. So I know we've seen all of this stuff before, so again, there should still be quite a bit of review for the first few sections of Chapter 1. Alright, let's get going here. Next. Okay. Alright, so write an expression that represents the area of the triangle, or rectangle. This is definitely a rectangle. Okay, so to find the area of a rectangle, it's just area equals length times width. Or you can say base times height, whatever you want to do. Area equals base times height. It all is the same. So if I'm doing my length, that's going to be x plus 5. So I know area equals x plus 5 times my height, or my width, which is 8. Okay, I put x plus 5 in parentheses because I'm multiplying that all by 8. Now, what I'm going to do is I'm going to multiply these things together. So, basically, what this is trying to teach you is how to distribute. So, let's just say that this much right here is 5. This much right here is going to be our x, which we don't know. That's just x. If I want to find the area of this part here, I'm just going to do 8 times 5. 8 times 5 is 40. If I want to do the area of this part here, I'm going to do 8 times x. 8 times x is just 8x. Okay, so the area of the whole rectangle would be those two added together, which would then come out to be 8x plus 40. We can't add those together because they're not like terms, and we'll talk about that in a second. But we can also just distribute through, so what distributing means is we're going to multiply 8 times everything on the inside, each term. Okay, x is a term and 5 is a term, so 8 times 5 gives us our 40, 8 times x gives us 8x, and then we're still adding them together. So that would be the expression to represent the area of that rectangle. Okay, so then looking at this one, we want to simplify these expressions, which means distribute the multiplication, the factor through. So this one I'm going to do 3 times x and 3 times 8. 3 times x gives us just 3x. This plus is still a plus, so plus 3 times 8, which is 24. Well, that's definitely 4. Whoa. 24. Okay. And that's simplified. So remember, distributing is kind of like the opposite of factoring. Like right now this is factored. If I want to unfactor it, I'm going to distribute. So this one, the negative 7 is on the right side over here, but I can still distribute it just the same way. So negative 7 times 5b gives us a negative 35b, because the b stays the same, and 7 times 5 is 35. Negative 7 times negative 4, we're going to think of this as a negative 4, becomes positive 28. So because it's positive, I do plus 28. Alright, and that's distributing. Okay, I'm not going to do these. Let's do D. We can do D together. So D, we have this negative y on the right side here. I'm going to distribute it through to this one and to this one. Okay, negative y times 2y. Okay, that's y times y, and we talked about how to do that in chapter 0. Y times y is just going to be y squared. Okay, and then we have negative times 2, which just gives us a negative 2. So we get negative 2y squared, and then we have negative y times this negative 1 here. Negative times negative becomes a positive or plus. 1 times y is y. So that would be D. Okay, you guys can go ahead and try A, B, and C. You could pause in 3, 2, 1, go. All right. Good job doing all of those. I'm sure you did all of them and got them all correct. Okay, so then let's look at something like this. How would we simplify this expression? So we have 7 plus 2 all over 5. So typically, what I would do anyway, is I would just add the top together. 7 plus 2 is 9. 9 over 5. And that fraction can't be simplified, so we're just going to leave it like that. But we can also write this as 7/5 plus 2/5. Okay, so basically what I'm doing is splitting this into two different fractions. So 7 over 5 and then 2 over 5. And then I'm still adding them together because it's a plus there. And then they have the same denominator, so our denominator stays the same. 7 plus 2 gives us 9. Okay, so you're probably wondering, why are we doing this? Great question. Well, if we look at this one we can't simply just add the top because 7x and 2 are not like terms. Remember, like terms, I think we're going to get to that. I guess we'll see. But like terms, they have to have the same variables. And because this has a variable, this does not, we can't add those together. So this is what sum or difference is equivalent to this fraction. So basically what it wants us to do is write it as two separate terms. So I'm going to do the same thing. I'm just going to divide everything by 5. So 7x over 5. So that's this part. Plus this part. 2 over 5. Okay, so those are the same thing. I could even write it as 7/5 and put the x in the front like this. Plus 2/5. Okay, so either of those is the same thing. All three of these. That's what it means when it says write the sum or difference. Sum means plus, difference means minus. Okay, and when we do this, so let's look at C here. I'll do C with you. Okay, so C, we can split it up into 15 over 12 plus 6 over 12x. Okay, and then what we can do is we can simplify the fractions. So 3 goes into both 15 and 12. So if I divide by 3 here, divide this by 3, and then 6 goes into both of these. So I can divide this by 6, divide this by 6. Okay, so then what I get is 15 divided by 3 is 5, over 12 divided by 3 is 4, plus 6 divided by 6 is 1, 12 divided by 6 is 2x. Okay, so this is the same as 5/4 plus 1/2 x. So, again, you're just writing the sum or difference, and you should always simplify your fractions. Okay, so if you're going to write it like this, make sure these fractions here and here get simplified before you move on to the next one. Okay, go ahead and try the rest of these. 3, 2, 1, pause. All right. Moving right along here. Okay, so this says we have the multiplication property of -1. Okay, this just says that -1 times x is the same as negative x. Okay, or for example, I can rewrite an expression like this as -1 times x plus 6. So if I change this to -1 times 2y minus 3x, and I want to simplify it, I'm going to use the distributive property. So -1 times 2 is -2. -1 times -3x is a positive 3x. Okay, and now it's simplified. And basically, whenever you have a negative on the outside and you put it through, all of your signs on the inside are going to change. So notice this became a negative, this became a plus, this right here, that sign. Okay, so when you distribute a negative through, all the signs change. Okay, eating out. So we're talking about deli sandwiches here. So we can use the distributive property from mental math. Deli sandwiches cost $4.95 each. What is the total cost of 8 sandwiches? Use mental math, which means don't type this into a calculator. I know it's hard for some people, but we can do this with mental math. Okay, so if we think about this, $4.95, if we were to estimate, that's basically $5, right? So I know this is going to be 8 times $4.95, or 8 times 5, because it's about $5, but I'm 5 cents short of $5, so this is really just 5 minus 5 cents. Okay, so then when I think about it, 8 times 5 gives us 40. 8 times 5 cents is 40 cents, so minus 40 cents. So really these sandwiches are going to cost us $40 minus the 40 cents, because we're taking off 5 cents for each sandwich, and that's going to give us $39.60. Okay, so again, just mental math. See $4.95, round it up to 5, and then just take off whatever you round it up to. So 40 minus 0.40. Okay, next, wait to stop. Okay, now combining like terms. I know that we've done this quite a bit lately, but these are like terms because they both have x squared, and they have the same variable, which is x, and those variables have the same power or same exponent, which is in this case 2. Okay, so when they have like terms, like the x squareds, we just add the coefficients together. The coefficient is the number that comes before the variable. Okay, so 8 is a coefficient and 2 is a coefficient. When we add those together, we get 10. X squared, and that stays the same. So this is not going to be x to the 4th, because remember that's when you're multiplying. So this is like having 8x squared, and then you have 2 more x squared. So total we have 10x squareds. Now b here, we've got a bunch of different terms. There's 1, 2, 3, 4, 5 terms. They're not all like terms. So we look at these, look at 5x. Is there any other just x's? Yes, that 3x there. It's a negative 3x actually. So when we combine those, 5x minus 3x, that minus stays with the 3, I get 2x. Okay, and then we have this negative 3 here, which is what we call a constant because there's no variables. And we can add it with our other constant, which is this plus 4 here. Negative 3 plus 4 gives us a plus 1. And then we still have this 6y left over. It doesn't have any friends. It doesn't have any like factor or like terms, so it just has to stay by itself, 6y. Okay, so then we rewrite it here. We get 2x plus 1 plus 6y. And notice none of these have the same variables anymore, so none of those are like terms. Okay, and then this just wants you to go through and simplify. So I'll look at C with you. So if we look at this, we have 7y cubed z, we have 6yz cubed, and then we just have y cubed z here. So they have the same variables, y and z, but they have to have the same exponent also. So this one's actually y cubed, this is just y, so we can't add those together. But this one is y cubed also, so I can add these two together. Alright, so we're going to do 7y cubed, and then our z's are the same too, because this is just z, and this is just z. So we can add these together. This is like 1. So 7 plus 1 gives us 8. Variables stay the same, y cubed z. And this one we just bring down, minus 6yz cubed. Okay, and we can't combine those because, like I said, these don't have the same exponents. So this is the final answer there. Alright, you can go ahead and try A and B. They are simple. just adding the coefficients together. All right, that's all for today, folks. I will see you guys later. Don't forget to like and subscribe, comment below.